Okay, here's what we investigated yesterday. We had a little bit of fun. I got to get some candy bars to some people, Mr. Dewitz and Mr. Wally. Show that they are the master mathematicians of all. Apparently, they have cheated. I learned that some other people actually found out how to do the second calculate option and generated a guess. And no, I'm saying other people did. You guys didn't, but other people found the second calculate option. And so, and then made an educated guess based off that. So I won't call anybody a cheater because apparently you're not allowed to do that nowadays. You can't say liar, like, oh, that person's a liar. Oh, that's bad. So. Oh, you can't say fake news. Okay, all right. Okay. Okay. So here's what we have. We are going to build off what we did yesterday. We're going to talk about the area problem. And so there's two really big problems in calculus that really define, how we arrive at the rest of calculus. That is, number one, how do you find the slope of a line tangent to a curve at one point? So that idea of slope at one point. That seems impossible, but we made it no big deal. And that is the basis for what we call differential calculus. This is different. Now, the big idea is how do you find the exact area bounded underneath the curve, especially when that curve does not fit the shape of a circle or a trapezoid or a sector. How do we find that exact area? Yesterday, you guys were working. You were drawing some shapes. You were doing pretty good work. At the end of the day, you were merely coming up with estimations. In fact, your calculator came up with an estimation. We want an exact value. And that's hard to do. But we're going to teach you how to do it, and we're going to teach you how to do an infinite number of rectangles. Yes. Sure, yeah, shaded region. So the area bounded between A and B underneath that curve is the exact area we want to find. So let's start basic. We're going to start by drawing rectangles. Again, people think that this is kind of childish. Trust me, many people struggled to draw the rectangles appropriately during first or second hour. So please make sure you're doing this well. All right. So I have this curve. It's f of x is equal to x squared. I want to find the area bounded between that, the x-axis, and x equals 4. And we know that our attempt is going to be a pretty bad estimation, but we're going to do it anyway. Draw that vertical line so I can see that that's the exact area I want to be able to find. Is everybody okay with this so far? Okay. I want to start by dividing it up into two rectangles. What is the total width of my interval right now? 4. So if I draw two rectangles, what's going to be the width of each rectangle? 2. So therefore, from 0, I go over to 2, and then I go over to 4. Before I start drawing these rectangles, I have to let you know that we are going to do a special kind of rectangle today. For example, see this rectangle between 2 and 4? I could either draw the rectangle like this, or I could draw the rectangle like this. The question is, do you make the height of the rectangle from the right side of the interval or from the left side of the interval? We're going to make it today, all of them from the right side. Now, it's different because tomorrow we'll look at left side, we'll look at trapezoidal, we'll look at midpoint, we'll look at different options. But today, everything is right side. Got that? Okay, I totally erased everything. Let's try this. Undo. Okay, great. There we go. So, I've got the 2. And so within this interval right here from 0 to 2, I draw the height of the rectangle at 0 or at 2. 2, because that's the right-hand side of this interval. So I draw up to the curve, and I draw it straight over, and then down to the other value. For 4, between 2 and 4, do I draw the height at 2 or the height at 4? I draw it up to the curve, I draw it over to 2 and down. Yep, they start to look like bar graphs. So what I have now is the area is going to be equal to, what's the width of the first rectangle, times what is the height of the first rectangle. How do you get 4? Take the 2 and square it. So you plug it into the function in order to get the height. This has a coordinate of 2, 4. So 2 times 4 plus 2 times, this has a coordinate of 4, 16. So 2 times 16. Now, I know that it's not a big deal right now because we only have 2 rectangles. But when I have 8 rectangles, it's going to become a lot easier if I factor out the width. Width is 2 times 4 plus 16. 4 plus 16 is 20, times 2 is 40. Is it an overestimation or an under? Yeah, it's pretty bad, isn't it? Okay, well, the whole idea of the calculus is to say, well, let's get a better estimation. If we want a better estimation, what should we do? Make more rectangles. So let's try 4. Okay, what? Who said? Oh, you had the incorrect answer. All right, so yeah, it's up to you. You could probably draw it right in there. But 4 rectangles, what's the width of each one going to be then? 1. So I've got 1 and I've got 3. And do I draw the height at 0 or the height at 1? Do I draw the height at 1 or 2? At 3. At 4. So what I could do now is, according to my last formula, just the area is equal to the width, which is 1 times the sum of the heights. What's the first height? Yeah, it's a parenthesis. So this is 1. That's my width. What's my first height? 1. Second height? Whoop. 4. 9. 16. So 1 plus 4 is 5, plus 9 is 14, plus 16 is 30. So 30. We said it was an over approximation. So did we get rid of some of our error? Yeah, in fact, we got rid of a lot of it. That was nice. You do 8 on your own. at 25.5. Okay. If you want to know the actual answer is 64 thirds, which is 21.3 repeating. Okay. And I'll teach you where you'll be able to figure that out really quick eventually as well. Okay. So we all go to 25.5. Okay, let's start looking at a little bit of our homework so you can, practice it a little, and then we'll move on to other stuff. You guys are funny, you know that? All right, here we go. So we have this curve, negative x squared plus 4x plus 7 over the interval negative 1, 5. I'm going to help you start to set it up, and then you'll be good to go. But you guys are really good kids. You're good at math, but some of you really struggle to see what the graph looks like at all. Okay? You see a curve, and you're like, I have no idea. Yeah, it's upside down, but let's get a little bit better idea of where it sits over that interval negative 1 to 5. So let's just graph it with our calculator, okay? On the AP exam, they're very good about either giving you the graph or allowing you to use your calculator in order to sketch the graph when it's needed. So, so I plugged it in. I sketched a graph. It looks like it moves just to the side of negative 1 and then just to the side of 5, right? So if I plot, say, negative 1, 0, 1, 2, 3, 4, 5, and it first says that we would like to do 2 rectangles. What is the entire width of the interval? The width is 6, so the width of each rectangle would be, so the width is going to be 3. So at what spot would I divide it into the 2 rectangles? At 2. So my first interval for my first rectangle is from negative 1 to 2. Do I draw the height at negative 1 or do I draw the height at 2? Draw the height at 2. So it look like that would be an overestimation or an underestimation. According to how I've drawn it, it looks like it's a little bit of an over, but who knows? Maybe I didn't draw it very well. And then from 2 to 5, do I draw the rectangle at 2 or 5? Yeah, that doesn't look like it's a very tall rectangle. That looks like it's definitely an underestimation, right? Okay. So remember, our formula is going to be the width, which is 3, times the sum of the heights. How do I calculate the first height? Yeah, so if you want to, you can go to your table and then just plug in 2 and 5. Whoop. I get 11 and 2. 13 times 3 is 39. 3. What I want you to do is see if you can do the 6 and the 12. And if you get past that, move on to the next problem even. The answer key is up here. But I'm going to give you until lunch to work through this. And then after lunch, we'll start working on the other pieces that you need to learn. But it is a little bit different. So let's look at example 2 in your notes. It says, use the following table to determine an approximate area bounded beneath the function over the interval -2 to 6 using 2, 4, and 8 rectangles. Now, if I have a region bounded from -2 to +6, what is the width of that interval? 8. So if I have an interval of 8 units, and I'm going to divide into 2 rectangles, what's the width of each rectangle? So I have 4 times the sum of the heights. Now, here's where you got to be smart. You can't count these number of x values. There's actually 9 of them. But yet we have 8, or we're using 2, 4, and 8 rectangles. You got to think about the interval. I'm going to start at -2, and if I move 4 units, that would bring me to +2, right? From x equals -2 to +2 is my first interval for my rectangle. The second one would be from 2 to 6. So the left side of the interval is -2. The right side of the interval is +2. Yes. No. I think in the last example or no, we did 2 and 6. You could have an odd number as well, and it's no big deal. It's no big deal. So in this situation, though, we have, I'm going to identify the height at 2. What's the height at 2? It's 7. And then I identify the height at 6, and it's 6. So I get 4 times 13, which is 52. Now I'm going to have 4 rectangles. What's the width of each rectangle would be if there's 4 of them? The width is 2. Now, here's the problem. Here's what a lot of people are tempted to do. When they see 2, they just look at -2 and -1, and they evaluate the height at -1. You have to go a width of 2. That's a width of 1. So a width of 2 would mean we go from -2 to 0. We go from 0 to 2. Go from 2 to 4. We go from 4 to 6. You see that? And again, today we're always focusing on the right-hand side. So what is the first x value that I use to evaluate a height? 0, and the height is? So I have 2 times 1 plus. Good. So I have 8 plus 14 is 22 times 2 is 44. Whoop. If I have 8 rectangles, what's the width of each one going to be? Yeah, so you can see that each one of these is an interval. And I'm not going to draw every single one, but I'll draw the first few. You can see the first interval is from -2 to -1. Where do I evaluate the height? -1. So do I ever evaluate the height at -2? No, not if we're doing the right-hand side. If we chose to do a left-hand side, then we would. And which one would get left off then? The last one would get left off. And that's what we'll look at later. Okay, so right-hand sum, we're going to evaluate. So we have 1 is our width, and we're going to do 10 plus 1 plus 5 plus 7 plus 16, 8, 5, 6. Yes, you would. Yep. And what's really cool is that if you take the left and the right and you average them, hopefully you'll get a better approximation then. And the left and the right, we'll look at that tomorrow. Actually, the average makes the trapezoidal, which is a really good estimation. So we'll talk about that later. Okay, anybody got an answer here? 58. Now, some people during second hour didn't really like that. They said, well, 52, when we went to 44, we thought the 52 was probably an overestimation. Most of the time, if you have a nice behaving curve, you can see it. But look at my values. I go 5, 10, 1, 5, 7, then up to 16, 8, 5, 6. This is a really kind of weird behaving curve. So it doesn't necessarily, it's really hard to come into a nice overestimation or underestimation. So don't worry if these values jump around on a table like that. Okay? All right, let's do the last type of example. And now we are not given a table and we're not given a function. It just says, look at the curve, estimate, approximate the area over the interval 0 to 8. So if I'm going from 0 to 8, my width is 8. What's going to be the width of each rectangle if I do 2? 4. So I have 4 times, and we do 2 rectangles. So I go from 0 to 8, so I'm going to divide it at 4. So I'm going to draw a rectangle here, draw it up to the function, then I draw it over to the 0. So you have to make sure that you're drawing it to the height of the curve at the x value at which you're trying to find the height. And you just draw it straight over then to your other interval side. Okay, where's the next spot I draw it? At 8. Again, I draw it to the curve. Make that dot and then draw it over and back down. So I have 2 rectangles. Does this look like it'll be an overestimation or an underestimation? Underestimation. So let's just estimate. So we got 4 times. What's the approximate height at 4? About 9. Approximate height at 8? Or 4, sure. So I've got 13 times 4 is 52. Now, I'd be pretty lenient. If you come up with a value somewhere between, say, 45 and 60, you're probably pretty close. So why don't you see if you can do the 4 and the 8? I got about 60 for 4. Is right around there. It's really nice with the smartboard when you draw the extra rectangles. You don't even have to really erase as long as you just go to a different color. Well, this would be an example. So, like, next year we're doing Chromebooks. It would be really cool if they had a touch screen so you could do something like this. So yeah, so you guys are fortunate because you guys you're allowed to write your answers in a pencil. Next year I'm requiring that all math assignments be typed out using computer software. So I'm kidding. I had to do that in college. We had a $500 computer software called Maple, and it's really cool. It's super powerful. It's awesome. And so anyway, yeah, so we would use that. Um, no, no, there's a lot of jokes that went along with like that, but at the end of the day, it's pretty hardcore math stuff. So, how about 8 rectangles? What'd you get? About? Okay. What? Oh, the very last one, right, like there. Okay, sure, yeah, yeah. Okay. That's all the notes. Um, trust me. No, you guys, I'm not. When I mean, it's pretty easy to grade this. If you're putting numbers like 2, 16, 5. Or no. Here's what people do instead. They're not putting in these numbers. They're putting in 1, 2, 3, 4, 5, 6, 7, 8. They're putting in the x values. They're not even looking at the heights. They forget what they're doing. They're like, oh, well, I think I add up these numbers. Yeah, I've never had anybody get this problem wrong on the test unless they start entering the x values instead, because they can't remember what they're doing. So don't worry. All right, so your assignment is the worksheet. I believe that the worksheet is posted online for an answer key. I'm sorry, the packet. So we'll call this one a packet.